Question 11. This question is from topic circular measure. In this question, we have a picture that consists of an isosceles triangle AOB where OA equals to OB and a sector OCDEO of a circle with center O. The line AB is a tangent to the circle and the value of the angle AOB is 1.8 radians and the radius of the circle is 12 centimeter. In the first part of this question, we have to show that the distance AC is 7.3 centimeter up to 1 decimal place. Now, let's draw a perpendicular line from O to line AB. And let's call this line OM. So, yeah. Now, this line divides the triangle AOB in equal 2 halves. So, angle AOM is 1.8 divided by 2 is 0.9 radians. Now, we have a right angle triangle AOM. So, we can write in triangle OAM cos 0.9 equals to the adjacent side OM over the hypotenuse OA. Now let's make OA as subject, so we can write OA equals to OM over cos 0.9. But OM is the radius, so OM is 12 centimeter. Now let's use this value. We can write OA equals to 12 divided by cos 0.9. Now let's use the calculator. We have to make sure that our calculator is in radian mode, and using the calculator we get the value of OA is 19.3 centimeter up to 1 decimal place. But let me draw a line first here. But OA is AC plus CO. So let's write this relationship. OA equals to AC plus CO. So we can write AC equals to OA minus CO. But so far we found that OA is 19.3 centimeter and CO being the radius 12 centimeter. So let's use those values. AC equals to 19.3 minus 12. So finally we get AC equals to 7.3 centimeter. So now we have proved the first part of this question. Now let's move to the second part of this question. In the second part of this question, we have to find the perimeter of the shaded region. Let's write all the lengths that consist the perimeters. So here the perimeter is the arc length CDE. So let's write arc length CDE plus AC plus BE plus AB. Now let's try to find each of the lengths individually and then add them together. At first, let's deal with arc length CDE. So arc length CDE, according to the formula of arc length, we can write r theta. Here r is 12, so let's write 12, and theta is 2 pi minus 1.8 radians. How? Let me show you in the picture. Here, this is 2 pi minus 1.8 radians. So now let's use the calculator to get the value, and we have found that the value of the arc length CD is 53.8 centimeter. Now we can write AC equals to BE. So let's write AC equals to B. Let's say Y. In isosceles triangle OAB, the side OA equals to the side OB, and OC equals to OE because they are radius of the circle. That leads us to AC equals to BE. But from the first part of this question, we know that the length of AC is 7.3 centimeter. So our BE is also 7. No, it's not C. Let me write it clearly. 7.3 centimeter. Now we need to find the length AB. And we are going to use the cosine rule of triangle. So in triangle OAB, using the cosine rule, we can write AB equals to square root of 19.3 squared plus 19.3 squared minus 2 times 19.3 times 19.3 times cos 1.8. So now let's use the calculator again. In radian mode, we can get the value of AB. AB is, let me complete my calculation here. AB is 30.24 centimeter. Now we have all the lengths. Now it's time to get the length of the perimeter. So perimeter is 53.8 centimeter plus 7.3 centimeter plus 7.3 centimeter plus 30.24 centimeter. Now let's use the calculator again. We can get the value of the perimeter as 94.68. So let's write 94.68 centimeter. Now let's move on to the last part of this question. For the last part of this question, we have to find the area of the shaded region. This shaded region has two parts. So area consists of two parts. The one part is the major sector CD. So let's write area of the major sector CDE plus the other part is the triangle OAB. So let's write triangle OAB. Now we have to find these areas individually, and later on we will add them together. So let's write area of the major sector is half times r squared times theta. Here r is 12 and theta is 2 pi minus 1.8. So let's write half times 12 squared times 2 pi minus 1.8. Using the calculator in radian mode, we can write the value is 322.8 centimeter squared. Now let's try to find the area of the triangle OAB. The length of the OA is 19 centimeter, length of OB is 19 centimeter, and angle between them is 1.8 radian. So let's write area of triangle OAB is half times AB sine theta. So half times 19.3, which is the length of OA, times 19.3, which is the length of OB, times sine 1.8. Now let's use the calculator in radian mode. We get the value as 181.3 504.37 centimeters squared. So let's add them together. So area of the shaded region, is 322.8 plus 181.37 centimeters squared. If you add them together, we get the final value as 504.17 centimeters squared. It won't be degree. 504.17 centimeters squared. So this is the area of the shaded region. Now question 11 is done. Now let's move on to the next question.